So we're starting the recording from for today's class, and where I go. Where is my chat window? Here you are. And okay.
Sir, এটা কি লেখা? আমি তারায় তারায় রটিয়ে যাব। ও রটিয়ে দেব।
এখান শুনো নাই?
না স্যার।
Shit. আচ্ছা, ব্যাপার না, হইতেই পারে। আমি মেসেঞ্জার ক্লোজ করে দিব এখন because I don't want this. We might need the Google search for relevant cases. আমরা কি P1 করতেছিলাম, I believe 3.1 শেষ হয়েছিল. So we are supposed to do 3.22 today first, and then we'll start try to move to the paper 2 worksheet. So let's get going.
স্যার একটা কোয়েশ্চেন ছিল।
একটা কোশ্চেন বলে হয়।
স্যার টার্বুলেন্ট ফোর্স আর ল্যামিনার ফোর্স কি?
এরকম হয়েছে।
স্যার এই যে আপনি আপথ্রাস্টের ভিসকসিটি ভিডিওটা দেখতে বলছিলেন না, তো আমি একটু এক্সট্রা ঘাটাঘাটি করছি, তো করার পরে এটা দেখবো।
Laminar flow is the type of flow where a fluid molecules, whether it's liquid or gas, each individual fluid particle's velocity is parallel to the general direction of the fluid flow. That's what we call laminar flow. Whereas turbulent flow is somewhat like where the particles can have sort of crisscrossed motion on their own, and they can have backward motion as well, which is a more indisciplined state of the individual particles, more common when the speed of the flow it gets higher than a certain point.
So that usually applies when an object is very deep inside the water body.
It is not dependent on how, on the depth of the water body. It is dependent on how fast the fluid is moving. For example, if I give you a bit of an idea, let's say if we drop a spherical object into water, not spherical object. Let's say if you drop a basic bombshell, which has a bit curved tip, but the end point is a flat, flush, cylindrical end. Let's say if you drop its tip down into water, as it will penetrate into the water particles will be sliding on the tip surface. But as they are gonna meet back when the behind flash part is gonna leave out. So what I mean is this. Let's say this is a thing, and then this is a thing.
A bullet.
Okay, so if you drop it into water, let's say if it goes down into water, the water particles can comfortably slide past this level and eventually get over here. But whenever this thing is gonna go back, water particles would have to actually rush into this process, into this place to fill this up. So over here, they're gonna experience a significant higher velocity that would not be available along the body. This bullet can, what can I say, slide through the water particles in fashion for this part, but over here the water particles will definitely undergo some sort of collision with each other, and it's not going to be meshed very, very, very beautifully. So that's sort of the location where we can have a bit of a turbulent flow. That's one example where we can have a composite example of turbulent and laminar flow together. However, if we don't design it like that, rather we design it to be like this. So in this case, what can happen? As it's gonna go down, water particles will slide past this point, and because we have a curved edge over here, water particles will be joined together smoothly as well. So you wouldn't have that turbulence happening. So this is gonna be more efficient in terms of flow. This is what I call a good aerodynamic design. Would say?
So basically, there should be a smooth flow for any object.
Streamlined flow. That's another word for laminar flow. Streamlined flow. Okay. So it is a good question. Yep. I appreciate it.
Regular key syllabus included amader.
No, this part was not included, but this question was asked from one of the videos that I referred to for the observation of upthrust. Oh yeah, I gave you this a homework to see the video for the upthrust explanation. So I'm gonna pick up the upthrust questions now, and then I'm gonna go for 3.2. Yes, forgot about it. So where is this upthrust question again? This one.
Sorry, number 13. 13.
So help me. What do you think should be the correct response for 13 and why? I assume that all of you know the definition of upthrust. You're clear with the idea of upthrust. If you have questions about the clear of the upthrust, first you ask me that. And I understand that you have seen the video and you have covered that material. Bolo.
Is upthrust basically normal contact force of weight?
No. Upthrust is the upward force that the fluid exerts on the body that is created because of the pressure difference at the top level and the bottom level of the fluid.
Yes, I got that. And I got your answer too.
Sure. So have a look. The question says the ball is falling at terminal speed in still air. The forces acting on the ball are upthrust, viscous, drag, and weight. What is the order of magnitude of these three forces? Now, a couple of things that we need to consider. I closed it. My bad. Let's say this is an object, ball, that is falling downwards. So its velocity is downwards. I'm trying not to label the velocity on the body of the object. I'm gonna label it outside because I don't want to confuse you kids. And as per the question, the velocity of the object is constant. So it's moving at terminal speed, which means it is not accelerating, which means the resultant force has to be 0. Now, since the object is going downwards, essentially, we have three forces acting on the object: upthrust, viscous, weight, or drag, and weight. Weight of an object always works by default downwards. So let's say I'm gonna label the weight with the brown arrow. Let's say the weight should be working downwards. Upthrust always works upwards. That's a given. The name itself says upthrust works upwards. And because the velocity is downwards, viscous drag is gonna work in the opposite direction of the velocity, because that's how viscous drag works. Viscous drag is about the fluid resistance against the motion. It's sort of the friction that the fluid provides onto the object as it is in a moving state. Stationary objects in a fluid would not experience drag, viscous drag. So in this case, the viscous drag, let's say I'm gonna label this as VD, that should also work in the upward direction. These arrows are not drawn to scale. I'm only showing you the direction of these arrows. This figure is not drawn to scale. So what we can essentially understand that these two are the upward forces. This is the downward force. Because this is undergoing terminal speed, so acceleration should be 0, which means the resultant force should be 0 as well. So if resultant force has to be 0, sum of upward force should be equal to sum of downward force. So I can write upthrust plus viscous drag should be exactly equal to W. This essentially tells us that among these three forces, weight has to be the biggest one. Try to understand. Among these three things, weight has to be the biggest force, because the sum of these two is equal to weight. Can we establish that factor, everyone?
Yes.
Yes, sir.
All right. So this is the scenario. Therefore, upthrust plus viscous drag is equal to weight. And since this is a scenario, so the question is asking us that what is the order of increasing magnitude of these three forces? Increasing magnitude means you're going to start from the smallest, then bigger, 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 and then bigger. So you're going to slowly have the order in terms of biggest value, which means the biggest force has to be weight, which means these two are out of question. C and D are not our preferable choice because weight is over here. Now the question is, between upthrust and viscous drag, which one is supposed to be the bigger force?
Viscous drag.
Now, here's the deal. Try to understand. It is falling through still air. Have a look at the medium. It is falling through still air. Why is this important? because the upthrust was defined as the density of the fluid multiplied by the volume of the object multiplied by gravitational acceleration. This was the equation. It is the equation that measures upthrust. So you need to understand that the ball is supposed to be a solid object because that's what typically it is, and the medium through which the ball is falling through is still air. Density of air is actually very, very small. It's about 1.29 kg per meter cube. So if you consider the two forces that if you consider the two forces, viscous drag and upthrust, logically speaking, that because the density of air is too small, the entire product of all of these three things is going to be also significantly small. Now there is a question that you can always ask, that can it is it going to be always true? Why cannot what I'm trying to imply is that upthrust should be the smallest of the forces and viscous drag would be slightly bigger. The reason I'm giving you to tell that upthrust should be the smallest of the forces, because the density of air, the density of fluid in this case, which is air, still air, density of the air is actually quite small. That makes upthrust to be quite small as well. So my proposition is that the increasing order force should be upthrust, smallest of the forces, viscous drag, slightly bigger, and the biggest of the three, because these two sum is equal to weight. This is A should be the correct answer. You can argue that we don't have any mathematical values available for this thing. So how are we supposed to understand that this that the upthrust is supposed to be the smallest force? This is because the object is falling under gravity, and you have to, and the medium is still air. So one way to explain that what is actually the upthrust is, one theoretical way to explain this thing is the upthrust force is always equal to the weight of the displaced fluid numerically. So what I mean, that try to understand, this is the definitive formula for upthrust. Here we have given volume of the object. This can essentially be replaced as the volume of the fluid, volume of the displaced fluid, that is. So density of the fluid into volume of the displaced fluid. Displaced fluid means what? If this is the entire object which has a volume of its own, let's say I'm going to fill this up by a color, let's say red. So this object is occupying some specific volume for its own as it is falling through the atmosphere. For that to happen, it will occupy the volume of its own. So within that volume, the atmospheric air cannot exist. So the ball would have by default replaced the atmospheric air and occupy that equal amount of volume. So whatever the volume of the object is essentially equal to the volume of the displaced fluid. So this is the density of the fluid, this is the displaced, this is the density of the fluid, which is the basic formula. This is the volume of the displaced fluid, which is exactly equal to the object's volume, multiplied by gravity. Now think about it. If you multiply density of the fluid into volume of the fluid, you're going to get the mass of the fluid. So I'm going to write the mass of the fluid, which is exactly equal to the volume of the object, into G. So now you can get a good, you should get a better understanding that the ball, which is supposed to be a solid object, it could be a hollow ball, it could be a football, tennis ball, or it could be a solid steel ball, or it could be a bowling ball, for example. The ball is made up of a solid object. So its mass is supposed to be significantly large, and that same volume of air that the ball occupies should have a very small value because the density of air is so small. Air is such a light material. If you wonder, air is a material? Air is a material because it is made up of molecules. But it is very, very light because it is in gaseous state. The molecular spacing is quite large compared to the other things that we have around. So that's why the upthrust is supposed to be the smallest of the forces. Viscous drag has to be the second one. Weight has to be the biggest one. You can still argue that we don't have any values. How can we do this thing? I mean, there is no answer beyond. I don't have a better explanation to explain to convince you of this fact. This manipulation of this equation is what I can tell you from my understanding, to give you a good idea that how can we compare these two forces. I mean, and also you need to have a gross understanding of where the upthrust is coming from and why this has to be the smallest force, because it is equal to the weight of the displaced air volume by the object. So that cannot be very large. That has to be very small.
Sir, would upthrust still be smaller than viscous drag if the medium was in still water?
That might be, that might not be. For if you replace the air with water or any other liquid material, then we would essentially require magnitudes of this variable. Other than actually calculating them, you cannot directly go for your answer. For air, we can consider this because comparing the density of say, solid object and air, solid objects are supposed to have, I mean, multiple folds of order of magnitude bigger density. So that's why the upthrust is considered to be significantly small for still air. But if it is in any other liquid medium, for example, water or oil or anything else, we would require numerical values to actually calculate them, and only then can we take a correct answer. Yes, sir.
Yes, sir.
Anyone else? Any question?
স্যার সবসময় কি এয়ারই থাকবে নাকি মিডিয়াম চেঞ্জ হতে পারে?
হ্যাঁ, মিডিয়াম চেঞ্জ হতে পারে, বাট এয়ার থাকলে আমরা আপথ্রাস্টের ভ্যালুটা অনেক স্মল হবে সেটা অ্যাজিউম করতে পারবো। মিডিয়াম চেঞ্জ হইলে আপথ্রাস্টের ভ্যালু ক্যালকুলেট করার জন্য আমাদের নিউমেরিক্যাল ভ্যালুগুলো কোশ্চেনে থাকতে হবে। অন্য মিডিয়াম দেওয়া থাকলে বা ডেন্সিটি একটা মিডিয়াম দেওয়া থাকলে আমরা ওই মিডিয়াম রিলেভেন্ট আপথ্রাস্ট কত হবে সেটা র্যান্ডমলি গেস করতে পারবো না, which we can in this question থাকতে পারে। The answer to your question is yes.
মানে স্যার ডেনসিটি বাড়লে আপথ্রাস্ট বাড়বে ওরকম কিছু বলতে পারবো না আমরা?
অবশ্যই বলতে পারবো। এই যে density of the fluid is a direct variable which affects the upthrust.
Oh, okay.
So if you place the same object within the denser medium, you're gonna definitely have a much higher upthrust.
Okay.
Sure. The other question that I skipped was this one. Take a look at this one. I'll take it onto the let's paint. আরো খারাপ অবস্থা হলো। Can I dynamically zoom this? I think I can do this. But does it help?
Somewhat.
Question টা পড়ো। A hailstone initially stationary at the base of a cloud falls vertically towards the earth. The diagram shows the magnitudes and duration of the forces acting on the hailstone as it starts to drop. So as it starts to drop, the viscous force is zero, because like I said, that viscous force is the friction force as any object tries to pass through a fluid medium. If the object is stationary, then you will not have the viscous force. That's one thing. And then the initial upthrust is very small, because in this case the object is falling through atmosphere. So upthrust is equal to the displaced volume weight of air. That's why it's a small value. And gravitational force weight is basically the weight of the hailstone. So that is the biggest force. So this is the magnitude of the forces at the starting point of motion. The question says further, which diagram shows the magnitude and the directions of these forces when the hailstone attains a terminal or constant speed in air of uniform density? Now, what is important for you to understand? Whenever the hailstone is falling downwards, pretty much like the earlier case. So upthrust has to work upwards, which is by default. And because the object is falling, the hailstone is falling downwards, the viscous drag has to work upwards as well. And the weight should always work downwards. Weight is not dependent on any of the variables that is available in this question. Excuse me. I have a call from my family. Sorry, it was my mom. I had to pick that call. So what is happening over here? The weight of the object is not going to be varied because the weight has a fixed value that is dependent on the mass and the gravitational acceleration. So throughout the entire case, the weight will be same, which you can see available for all of the individual answer choices that we have. The downward arrow length is same for all the option choices, which is good. Number one. Number two, the object is going to fall downwards and it is going to fall through uniform density of air. Now the equation that I just wrote a bit earlier, that the equation, I'm going to write this over since upthrust depend on the fluid density multiplied by the volume of the object multiplied by G. As the hailstone is going to fall downwards, the volume is going to remain same, the density of fluid is same, because the question tells us so. The reason the question specifies this information, because you need to understand that as we go further above from the earth crust, the density of air actually slowly becomes less. The air becomes thinner and thinner and thinner. But for the sake of much simplified understanding of the problem, they have asked us to consider that the air should be of uniform density. I'm going to cover the idea that what if this was not mentioned, then what could have been a possible correct answer. I'm going to cover that as well. But let's consider that the air now has an uniform density as per the question determines, it tells us. So the rho F should be a fixed value. V0 should be also a fixed value. This is the volume of the hailstone, not going to change as the hailstone falls through the atmosphere. G is a default fixed value. So the upthrust should not change as the object falls downwards, which means this arrow length should also be same and must also be working in the upward direction. All that remains is how much is the viscous force going to be. Like I told you in the earlier equation, that because the object is falling through the hailstone is falling through atmosphere, weight should be equal to upthrust plus drag. These are the two variables which needs to be equal to each other, which means to equate this length of downward force, we already have this much of upward force available. So additionally, we're going to require the remaining amount of upward force. So let's say we're going to require a viscous drag that should be somewhat of this much length, but this thing should not exist over here. This should be over here. The reason I'm drawing this over here to give an comparable idea that this is the upward value of the upthrust, and you would require the remaining amount of upward force so that the sum of these two upward forces perfectly balance out the weight, because that's exactly where you can have zero resultant force and your object can achieve terminal velocity or constant velocity. So based upon that discussion, which one do you think is the correct answer? Try to figure that out. If you have any question, you ask me. Which one do you think is the correct answer? বলো, at the voice channel করে বলো অথবা chat window বলো.
D.
Sir, B হবে sir.
Like D na B?
D for Dhaka.
Yeah, D for Dhaka. Yes. D is the correct response because the upthrust should not be changed and the upward drag should be the remaining length. So সবাই দেখো বুঝছো কিনা, এটা বুঝে গেছে কিনা ক্লিয়ারলি সবার কাছে? Do you have any question? Tell me.
So viscous drag এর কোনো formula নেই?
Viscous drag এর formula আছে. We can find out the viscous drag using Stokes law and Bernoulli's equation. Sorry, not Bernoulli's equation. We can find out the viscous drag using Stokes law, but that formula is actually considered to be a bit far-fetched for your syllabus, even up to your A2 level. So they did not incorporate any of the equation regarding fluid dynamics. So fluid dynamics was altogether got rid of in terms of calculation equation concept, but the idea-based questions are included. Ase. I mean, I can show you, for example, since we have access to internet, why not? Click. This is the viscous drag equation. Viscous drag force equals to half into rho into u square CD, which is a constant. A is the cross-sectional area or attack area of the through the fluid or disturbed area of the fluid. So this is the equation, but this is not introduced in your level syllabus, so we are not going to talk about this one. So you don't have to take this equation. You just have to understand the theoretical or conceptual implication of how that has to be processed. Vidasi? I hope so. So we're going to start 3.2. Any question from page number 10? Anyone?
Sir, 1.
A ruler of length 0.30 meter is pivoted at its center. Equal and opposite forces of magnitude 2.0 Newton are applied on the ends of the ruler, creating a couple as shown. What is the magnitude of the torque of the couple on the ruler when placed in the position shown? The formula for the torque of a couple is one of the forces multiplied by the perpendicular distance between them. The question says the ruler length is 0.30 meter, which means this diagonal length, if I just draw it over here, this diagonal length is how much?
0.3.
0.30 meter. But this is not useful for you because you need the vertical distance between them. So what you need, I'm intentionally drawing the vertical distance over here. I could have drawn it anywhere else. I mean, I could have drawn it here. I could have drawn it here. Let's say I'm drawing it over here. The reason I'm drawing it over here so that you can see the existence of a very beautiful right angle triangle, right? This is the hypotenuse, this is the angle. So how much should be this green line length by trigonometry?
Sin 30.
Sin 50. 0.30 sin 50. Now, that's the perpendicular distance. So to find out the torque of the couple, let's say show that torque like this, we're going to have to multiply this perpendicular distance with one of the forces, which is 2.0. So you just calculate how much is this, you get your number. Yes, sir.
Yes, sir.
Sadia? মানে যে কোশ্চেনটা করছিল সে বুঝে গেছে?
Yes, sir, বুঝেছি।
আচ্ছা, ওকে। তারপর
স্যার নাম্বার 2 টাও একটু বুঝিয়ে দিবেন।
শিওর। নাম্বার 2 তে বলছে the diagram shows four forces applied to a circular object. Which of the following describes the resultant force and resultant torque on the object? So let's take this question out and have a look at it. What I need you to understand, the resultant force would be 0 if you have equal and opposite forces on the object. So one of the easier way to observe this is that if you consider the sum of the objects along two axes, vertical axis and horizontal axis, and you can consider those up. If the object has individual equilibrium for both the y-axis and the x-axis, then we can say the resultant force is 0. That's one thing. The other thing is that if you have to consider for moment, you'd have to undergo some rigorous calculation. Some rigorous calculation is needed to find out the moment. So in that aspect, if you have a look over here, what you can see, this 30 Newton is working upwards, this 30 Newton is working downwards. Irrespective of your position, irrespective of the application point of the forces, if you just consider what is the vertical sum of these two forces, considering them as vectors, what will be the resultant vertical force?
0.
That should be 0 because one is working upwards and one is working downwards, so they're going to balance each other out. Like I said, we're not considering the moment yet. We're now only considering the resultant of the forces. So it's only the alignment and the value that is important. But if you consider for the horizontal axis, we have two 20 Newton force working to the right. So we're not going to have we are not going to have a 0 resultant force for the horizontal case because we have 40 Newton force working to the right and no force working to the left. So resultant force is non-zero. এই পার্টটা বুঝা গেছে কিনা?
Yes, sir.
That's
Yes,
one
sir.
thing. And then another thing that you can understand that, I mean, for this object, we can pretty much consider any of the location to be a pivot point. We can, for our judgment. So because we can choose the point, a convenient or a smart choice for that location can be the center. Let's say, because that would give us a bit easier location to judge the whole scenario. If you consider that the center is the pivot point, you should be able to understand that this 20 Newton and this 20 Newton should be cancelling each other out in terms of moment. Because if you think that this is producing a clockwise Newton, clockwise moment, this 20 Newton is producing an anti-clockwise moment. So these two are going to produce equal and opposite moment. So they're going to cancel out each other's moment value. But these two 30 Newton are not going to cancel each other out. Have a look. Because these two 30 Newtons are essentially producing a couple. Even if they were not a couple, for example, if this was, even if they were not a couple, you can see that this 30 Newton on this object is producing a clockwise moment, and this 30 Newton is also producing a clockwise moment, which means these two moments produced by the two 30 Newton forces needs to get added together. So the resultant moment is balanced for the 20 Newton, but the resultant moment is not balanced for the 30 Newton. These two things are not balanced. So for this scenario, the resultant force is non-zero, the resultant torque is also non-zero. D is the correct response.
এই অবজেক্টটা মুভ করবে কিভাবে?
Depends on whether the object is pivoted in point. One specific scenario that I can bring in to answer your question, Zarif, is that if we assume that this object is in the space, not pivoted anywhere, just an object that is free to move without any attraction from the surrounding, these are the only force acting on the object. This object is gonna spin in a clockwise direction, and as long as the torque will be available, the rotation of spin is gonna slowly increase, so it's gonna speed up in spinning speed as long as you make that torque available to it, and it's gonna accelerate to the right, so it's gonna gain a velocity to the right with an ever increasing velocity, because the resultant force on the right side direction is 40 Newton. As long as you make that 40 Newton available on the object, that is going to accelerate the object. So if I have to describe As long as all the forces keep working on the object, this object is going to accelerate horizontally to the right while gaining an increasing or gaining an increasing clockwise rotation speed. বুঝা গেছে?
জি স্যার।
Good. তারপর
Sir, 5.
5. Okay. Question number 5 is essentially not difficult, but I'd say it is meticulous. Meticulous because you have to have keen observation, use keen observation, and do some mental math in your head to be able to solve this question properly. So just to be able to manipulate this figure more conveniently, I'm going to bring it up to the free space. Oops, 2 meter got cut off. Okay. Oops. Better. Okay. So this is a pivot point as per the question, and we have all the individual forces available and we have all the individual dimensions available. So first thing first, to be able to calculate the moment produced by a single force, we need to know the value of the force. We also need to know the perpendicular distance from the pivot point onto that force. Now, if that perpendicular line is not already given to us, like I have told you in the beginning of the force and moment lecture, we might need to extend the force action line conveniently so that we can draw the perpendicular distance. So let's elaborate that idea piece by piece. So let's say I'm going to first calculate the moment of the 5 Newton force. This 5 Newton force is working over here. From this point, I cannot draw perpendicular lines over here. So for convenience, let's say I'm going to extend up this line in this direction, vertical force. So this is the line of action for the force. This is not perpendicular distance. The perpendicular distance is, let's say, this one. This is the perpendicular distance. So my question to you is that by just looking at the defined dimensions given in the question, how much should be the length of this red line? Don't respond in voice channel, right in the group chat. Let everyone figure out on their own. Observe defined dimensions that is given to you and try to figure out the length of the red line. You have to understand figures are usually not drawn to scale. Anaf and Saraf, তোমাদের আনসার একটু ভুল হয়েছে। Observe again. মিটার তাহসিনা ইউনিট দেওয়া লাগবে। Good. So have a look. For those who are saying it to be 1 meter, it's not 1 meter. What is the total length of this bar? 3 plus 1, 4. How much is from the right to the 5 Newton? 2. So how much should be this much? 3 plus 1. This is 2. So 4 minus 2 gives you how much? 2 meter. So let me write this up so that we don't forget this number. So this is the perpendicular distance. So I'm going to keep this over here. I'm going to use this information a bit later to do the moment calculation altogether. So that's one thing. And then this is going to produce an anti-clockwise moment. Just for the sake of not confusing it, I'm going to show an anti-clockwise moment direction over here. Let's consider this force. This force is working downwards. Same drill. This is 3 meter over here, which means I can extend this line up over here along this line. I can extend this force up over here along this line, which means that this force has a perpendicular distance of 3 meter from the pivot point, which is readily available to us. Big deal. So which means the moment produced by the 20 Newton force should be 20 Newton into 3 meter, because that's the perpendicular distance from this thing. You have to understand, perpendicular distance should not be drawn diagonally. The distance line should be perpendicular on the force line from the pivot point. Or in this case, what I'm trying to show you is that we did not draw the distance directly from the pivot line. Rather, we extended a parallel line along with the force line direction. So the force is working vertically downwards. We drew a relevant parallel line from the pivot point, and the distance was labeled here. This also perfectly works. So in this case, the moment produced by the 20 Newton force should be 20 into 3. That should be a clockwise moment. Let me write it this way. How about for the 10 Newton? What is the perpendicular distance for the 10 Newton force from the pivot point? Once again, I can extend this force backwards for a reference line, and I need to find out this distance. Let's say I'm going to label this as purple. I need to find out this distance. This is the perpendicular distance on this force. And how much is leveled? 2 meters. And in which direction is this force is going to produce the moment for?
Left, right.
No.
Right.
Moments are not to be said to be left or right. Forces can be left or right, up and down. Moment can be clockwise.
Anti-clockwise.
One of the easier way, let me tell this for everyone.
Anti-clockwise.
It will be anti-clockwise. Another easier way to find out the moment produced by a single force is assume that this is the only force available to this object. Disregard the existence of this one. Consider only this one. If an object is in this orientation, if you try to pull this object to the right, this whole orientation is gonna rise up. So this is gonna move to the right. So it's gonna start rotating in anti-clockwise direction, which means this is gonna produce an anti-clockwise moment. Beautiful. So we have 2 anti-clockwise moment, 1 clockwise moment. Let's go ahead for the calculation. Help yourself and see if you can find the answer. Calculation করে দেখো কত হয়, আনসার কত হয় আমাকে চ্যাটের নিতে লেখো। ওকে, সবাই ক্যালকুলেশন করে দেখো কত হয়।
30 আসছে স্যার।
জি,
এই যে 10 নিউটনের যে অ্যান্টি ক্লকওয়াইজ, এটা আমি বুঝতে পারলাম না কেন।
consider that this is the only force available to this object. Then how is this object going to move? Okay, I can help you with this one. Okay, let's say this is the force that we are applying on this object at this point. So what is going to happen if we try to use this point as our pivot and try to rotate the object? So let's say we're going to rotate it like that. Have a look. So if you pull with the force on the right, where this is a pivot point, this side is going to go up, this side is going to move to the right. So this is going to be the rotation direction for this entire lever.
Yes, sir. বুঝেছি।
Yes, sir.
Yes, sir.
Sure. So A is the correct response. Moving on. Anything else on this page? I don't think so. No. Page number 11.
Sorry, 10.
Sir, 9.
আচ্ছা ঠিক আছে, 9 10 যদি দেখাবো সমস্যা নাই। 9 দেখো। 9 is actually a bit can be a bit confusing. I'll tell you why it can be a bit confusing. Let's try to understand the whole situation. The question says a uniform ladder rests against a vertical wall where there is negligible friction. The bottom of the ladder rests on the rough ground where there is friction. Okay. The top of the ladder is at a height h above the ground, and the foot of the ladder is at a distance 2f from the wall. So wall has negligible friction, the ground has significant friction. Rough ground, smooth wall. And the distance is 2f from the wall. The diagram shows on the forces which act on the ladder, which equation is formed by taking moments. Now, like I said, the question says that this is this thing is that is, it rests against a vertical wall. Try to understand the meaning of this word. Rests against a vertical wall means it is currently stationary, which means the moments are perfectly balanced. So honestly speaking, we can choose to take moment about any point that we consider convenient for us. We have that opportunity. So the smartest choice for this kind of scenarios to take moments about is to choose such a point through which or towards which most of the forces pass through. What I mean is that if we can find out a point where most of the forces are going across, about that point, the moment of all of these forces should be 0. To give a better understanding, if I mark out this point, let's say this is the point. If I try to take a moment about this point, have a look at this. I'm choosing this point over here. If I choose this point, the moment, I mean, because I can choose the pivot point at my will. So if I choose this point for my pivot point calculation, for my moment calculation, then the moment about this point, the moment of the W force, this one, and moment of this force, both of the moments will be absolutely 0. Why? because both of these forces are passing through this point. So the perpendicular distance of these two forces are essentially 0 about this point. So because the moment of these two forces are going to be automatically 0, all that I have to bother is about this force and this force. So my calculation is going to become much too smaller. Do you understand the advantage?
Yes, sir.
Yes, sir.
This is a smart way to calculating moments whenever you are dealing with a scenario. But that might not be ideal in many cases. I mean, what I mean by smart and ideal, there's a bit of a difference, which I'm going to highlight in a bit. So for the timing, let's try and calculate the moment about this point. A pointer respect a force moment hobe hocche anti-clockwise or a force moment hobe hocche clockwise. Because the whole thing is rest against the vertical, so we have to understand that these two moments should be cancelling out each other. So what is the perpendicular distance from this point to the force F, which would be h, shown up over here? Or in other words, I could have extended this force line along this line, and if I try to get this line, this distance, this is going to be h as well. H and h should be equal. So we have a clockwise moment of fh, and if we try to calculate the anti-clockwise moment produced by w is working here, a is over here, so you can very well see that the distance of this w force working, which is the weight of the object, is a distance perpendicularly away from the pivot point that I have chosen. So this should be wa. Logic should tell us that this should be our good enough equation. The irony is that in none of these options we have this equation, do we? I mean, the answer to this question can be yes and no. You will not find out this exact equation in any of this equation. But if you try to simplify the equations that we have available over here, for example, we have a lot of undone calculation over here. For example, have a look. WA equals to FH plus 2 into WA. So you can essentially get rid of one WA from both sides, right? Do the side change.
Yes.
So what would this equation become? It will become this one. And this is basically your correct response. Because if you go for the other options, WA plus 2WA gives you what? 3WA equals to FH, not your equation. Here it should be minus WA should be equals to 2FH. This is not your equation. So this is supposed to be a correct answer. A is the correct response. এই পর্যন্ত বুঝা গেছে কিনা? I'm going to discuss further why this question actually popped up. I'm going to explain that. But এই পর্যন্ত বুঝা গেছে কিনা?
Yes, sir.
The other part is that if this is the easier way to do this, why did they even bother to write this equation? So here is what they did. I mean, this part of the explanation that you don't have to remember, but I'm just discussing this part, the upcoming part, so that you can understand why they wrote an equation like this. What they did is they took the moment about this point. Now, if you wonder how did I know this, I knew this from a lot of trial and error, and then I got to know this because I've been teaching this MCQ for years. So that's why I know. So I came to know about this point by trial and error. The CA people or any other person didn't tell me. Let's have a try to calculate the moment of all of these four forces. Now you have to calculate the forces for three forces. Which are the three forces? All the three forces which do not directly aim or get away from this point. You will see among these four forces, one of the forces is directly gonna pass through this point. Which force is that?
F.
WWF. Which force is gonna be passing through this red point?
F.
This one.
না নিচেরটা
না স্যার নিচেরটা
So left or left or the bottom left. So since this one is aiming towards this pivot point, we don't have to bother about distance moments. We can essentially go for the moment calculus for this one. Now, if I try to represent the moments over here by red, and let's choose a bit thicker arrow. About this point, this F is going to produce clockwise moment. This W is going to also produce clockwise moment. This W is going to produce anti-clockwise moment. So I can add up the moment of these two, and this should be equal to this one. So go ahead. F into H plus W into A should be equals to, here's the W, and how much is the distance over here? A plus A, that is W into 2A. If you simplify this equation, you'll see this is popping up.
Sir, like I don't get it. Why F into FH should be like equals to WA? I don't get it.
Because we took the moment for the first question, for this one. Yeah, I'll answer that after I finish up the discussion this part because you didn't respond in time. I'll get back to it, but you have to wait. Hold on, দেখো এই কোশ্চেনটা বুঝা গেছে কিনা?
Yes, sir.
So basically that's how they came up with this equation. So Asha, getting back to your question, I tried to take moment about this green point over here, and that gave us an anti-clockwise moment for the W force, and that gave me a clockwise moment for the F force. Do you understand these two directions of the moments?
Yes, I understand the directions.
Okay, and now if you consider the perpendicular distances of W and F individually, F is how far apart, perpendicular distance from the force F from this pivot point, how much is that? This line is how much long?
H.
2A, 2A.
No, not 2A. I'm saying that F force থেকে এই pivot point এর distance টা কতটুকু? How much is this vertical distance?
8.
That's why F into
8.
and
আচ্ছা,
how far is the W force from this point? That is this much,
yeah.
WA. So clockwise moment FH should be equal to anti-clockwise moment WA. বুঝে গেছে?
Oh, it is in equilibrium. That's why the two moments are equal.
Yes. It's amazing that how sometimes the interconnections can put audio effects into our voices. I mean, it's cool. DJ effects. Asha, you don't have any idea what I'm talking about, do you? Anyway, হ্যাঁ বলো, যারা বলো।
স্যার আমরা এখানে W যেটা উপরে আছে না না হ্যাঁ স্যার W যেটা নিচে অ্যাক্ট করতেছে WA যেটা বলতেছি আমরা মোমেন্ট যেটা হবে ওইটাকে আমরা FH এর সাথে মানে FH এর সাইডে রেখেছি কেন?
FH এর সাইডে মানে বুঝলাম না।
মানে FH প্লাস WA হইলো কেন?
হলো না কেন?
হইলো কেন? এটা না স্যার, এটা না
এখানে। ও আচ্ছা, এটার কারণ হচ্ছে when we consider this force, I mean considering this one as a pivot point, this F force was producing a clockwise moment. I should draw it red. This was producing a clockwise moment, and this W force was also producing a clockwise moment. These two are clockwise.
এটা মানে W clockwise কেন বুঝলি?
আচ্ছা ঠিক আছে, W কেন clockwise হচ্ছে সেটা আমি তোমাকে বুঝাই দিচ্ছি, don't worry. If you try to concentrate that, let's say nothing else exists. Where is the erase button here? Consider that nothing exists, but I will need chewing gum. I'll need these corner points. I'll leave it a bit of a trace for this one. Okay, I can erase, I can obliterate everything else. Let's say এগুলা কিছু exist করতেছে না।
হ্যাঁ, এখন বুঝতে একটু সুবিধা হচ্ছে।
That's exactly what I meant in the first place, that if you're trying to find out the moment duration for a single force, consider that that is the only force that is working on the object. So let's say if you now consider this is your pivot point and you have a force like this, how is this object going to rotate? This is going to fall down, right?
Yes, sir.
So, but I said that this is a pivot point, so you might as well assume that this object is going to rotate about this point. So you can consider that the distance over here is not going to change. I mean, there might be a bit of a support system which is going to keep this object going around, but I have erased all of the support systems just so that you can exclusively see the object and the force working on the body. Or I can make it even easier for you to understand. That assume this entire ladder to be considered as a single particle which is located at its center of gravity. What do I mean? Let's say this is the particle where the entire weight of the object is working. So let's say this is a small particle. So that is also another weight for more simplification. So you have a pivot point over here. Here is an object of W weight. The force is working this way. What would be the moment direction? I mean, should this force produce a clockwise moment or anti-clockwise moment?
clockwise moment.
Yeah, but Zara, can you see that?
জি স্যার
No, you don't. You
না
sound
স্যার জানি না স্যার বুঝেছি ইটস লাইক আমি যদি পিভট পয়েন্টটার মধ্যে একটা লাইন এক্সটেন্ড করি
beautiful.
আর ওয়েটের সাথে তাহলে তো ক্লকওয়াইজ মোমেন্ট হিসাবে ঘুরবে
Beautiful. So that's one another way to easily understand what type of moment you're gonna get. Consider one force and one pivot point exclusively. Try to unsee everything around, and that way you can very easily find out what direction of moment that you're gonna have. So that's why I wrote this as a clockwise moment. Clear?
How FH and WA cancel out each other.
FH and
Like,
WA
I don't
cancel out for this one,
understand.
but here they don't cancel out each other. Here these two get added because they are both clockwise, and this one was anti-clockwise. Mathematically, you can get this question in this one as well. All right.
Okay.
স্যার
Oh, these two.
Hello.
স্যার এই যে
Sir?
আচ্ছা একজন একজন করে কথা বলো হ্যাঁ সাদিয়া বলো
স্যার ল্যাডারটা মানে যখন এই ম্যাথসটা করবো তখন তো ওই পিভট পয়েন্ট সাইডে না নিয়ে এমন মাথা আসতে পারে যে মাঝখানে নিলাম
হ্যাঁ নিতে পারো কোনো সমস্যা নাই ইউ ক্যান
স্যার এমন করে মানে তখন তো হচ্ছে ডাব্লিউ যেই পয়েন্টটা আছে ওই পয়েন্টে পিভট নিলে ইজি হবে না মানে ক্যান্সেল হয়ে যাবে এর জন্য
তুমি যে পয়েন্টে পিভট পয়েন্ট ধরবা ওই পয়েন্টের ভেতর দিয়ে যে সকল ফোর্স পাস করবে বা ওই পয়েন্টের টুয়ার্ডস যে সকল ফোর্স অ্যাভেলেবল থাকবে ওই সবগুলো ফোর্সের মোমেন্ট জিরো হবে
থ্যাংক ইউ
You meant that if you take this point as a pivot point, this one as a pivot point.
ইয়েস স্যার
Yes, if you take this one as a pivot point, then this W force will produce you no moment. So this will be out of our equation. We have to calculate the moment for this one, and this one. বুঝা গেছে? You can take moment about any point, no matter which location that you choose as a pivot point. If your calculations and your observations are correct, you will always end up with this equation, irrespective of the choice of a pivot point. If you don't do mistakes, you're gonna end up with this equation. Simple. So let's have a look at this question. Have a read and give it a try, and then we'll discuss.
স্যার
Yes.
আচ্ছা আপনি শুনতে পারতেছেন
কোশ্চেনটা খুব ভালো করে বোঝার চেষ্টা করো দিস ইজ এ 3-dimensional figure, so try to visualize the situation for the orientation of the objects or orientation of the forces. That's important. That's really important. For one additional information that I'll tell you, which you might know, might not know, the purpose of a smooth pulley is to only change the direction of force without affecting the value. The purpose of a smooth pulley is only to change the direction of a force without affecting the value of it. Channel পড়ো না কেন চ্যানেল পড়ো আমাদের রুম অনেক ময়লা আমাদের না পাঁচটা সেন্টার ফুড নিয়ে আসো গোলাপি রঙের দুটা করে সেন্টার ফুড All right, question পড়ছো?
জি স্যার।
So let's go for the understanding. So a spindle is attached at one end of a center of a lever 1.20 meter long, and its other end is the center of a disc of a radius 0.20 meter. A cord is wrapped around the disc, passes over a pulley, and is attached to a 900 Newton weight. What is the minimum force if applied to each end of the lever that could lift the weight? Before I go ahead and tell you this question, the reason this kind of figures actually can be quite perplexing to many of us is because these simplified figures only show us the required components of the setup that is needed for us to do the calculation. These figures are not created along with the support systems that there is. What I mean is that apparently it feels like that this whole thing is floating in thin air. That's not the case. Because this is said to be a spindle, there would be some huge rectangular support, or rectangular, not actually rectangular. There will be some support system around this spindle. There'll be some support system around this spindle, which is going to keep this spindle in place. So let's say if I just fill this up by some color to give you a bit of a better idea. So we're gonna have no. Okay. So we're gonna have this thing that would be supported by some mechanism, so the spindle will be in its place. Similarly, through this hole of the pulley, there should be a shaft that is gonna keep the pulley in place as well. So if I just try to draw that shaft, which I think I cannot draw very properly, but I'll try. Let's say there's going to be a shaft that's going to be passing along like this. And this is going to keep the pulley in place. Thank you. Thank you very much. This is going to keep the pulley in place. So if you have to understand that these things do exist for the actual setup to physically create, but for the sake of simplified drawing, they did not show us this thing. So this can prove to be a bit difficult for some of us to understand the problem in the first place, because it looks floating. So that's the first thing that I wanted to introduce for additional help for understanding. You can see over here, this block is having a weight of 900 Newton, which is working downwards, which means this cord is going to pull on the pulley by 900 Newton. This pulley is simply going to change the direction with 900 Newton force, which is going to pull outwards along this track, which means along this line, we're going to have the same 900 Newton force, but that direction is going to be horizontal and in that way. What the hell? Better. I should place it here. Yes. এই পর্যন্ত বুঝা গেছে কিনা?
Yes, sir.
Okay.
আপনার কথা শুনে যাচ্ছে না।
স্যার আমার বুঝতে একটু কষ্ট হচ্ছে।
বলো কোন পার্টটাতে কনফিউশন? I'll help. বলো কোন পার্টটা বোঝা যাচ্ছে না? মানে কি ভয়েস শোনা যাচ্ছিল না নাকি কথা শোনা যাচ্ছিল না? মানে কথা বোঝা যাচ্ছে না?
না স্যার, দুইটা 900 সাথে কাজ করতেছে পুলি, আর ওই ওটা বুঝলাম না। ওই যে স্যার মানে কি ফার্স্ট পুলি আর ডিস্কের মোমেন্ট কি সেম, বাট ডিরেকশন আলাদা নাকি?
আচ্ছা, ডিস্কের পার্টটাতে আমি এখনো যাই নাই। I discussed up to this much part. What I'm trying to tell you is that the pulley is going to convert this downward force into a horizontal force. So the pulley converts the downward force of the weight, that is the weight of this block, into a horizontal force along this direction outwards. So the pulley is going to produce a tension onto the side of the disc. Side, important word, side.
Okay.
So now we are trying to find out what will be the value of this force F. Achha, just to make better understanding of this figure, because this is a three-dimensional figure, I can make sense of this figure because I am used to this kind of figures. But just to make good sense with you, I'm going to draw this whole figure from the top view.
Okay, sir.
So bear with me. Bad choice. Okay. Consider this as the top view, and let's say this is the string. So we now have this happening, and this is going to produce an anti-clockwise moment on this disk, which is going to be how far apart? 0.20 meters. So this is going to be 0.20. That's the radius of the disk, and the two forces are working out to balance out this force, because the question says that what is the minimum force if applied to the each end of the lever that could lift the weight. Minimum means that we are trying to achieve a critical equilibrium scenario where the moments will be exactly equal to each other. So this disk is experiencing an anti-clockwise moment. So the forces should produce a clockwise moment. So this force that is shown over along this direction, I'm going to show this up over here. And the other force, I'm going to show up it up over here. Both of these forces are exactly equal. So they essentially produce a couple. This figure is not drawn to scale because I cannot essentially make measurements. Now, what you need to understand, the entire length of the rod is how much? 1.20. 1.20 meters. So I'm going to just write this over here. So the torque produced by the couple of the F forces, that is going to be force into D. So that's going to be F into 1.20. By logic, this should be equal to the moment produced by this string. So this should be equals to 900 into 0.2. You are asked to calculate the value of the F. So that's the entire discussion. So check this out. If you have any question, feel free to ask.
Equation to the
Sorry?
না স্যার বলছিলাম ইকুয়েশনটার দিকে ফোকাস করতে।
ইকুয়েশনটা?
না স্যার বলছিলাম যে ইকুয়েশনটাকে স্ক্রিনের মধ্যে আনতে, তো স্ক্রিনের বাইরে চলে যাচ্ছিল তখন যখন
আমি যে ডান পাশে তোমাদের চ্যাট উইন্ডো আর পার্টিসিপেন্টস উইন্ডো বের করে রাখছি, ওই জন্য আমার এই পার্টটুকু তো আমি প্র্যাকটিক্যালি ইউজ করতে পারতেছি না, বাট আই ক্যান ট্রাই টু pull this a little bit like that. That works. Yes. দেখো ক্যালকুলেশনে কোনো কোশ্চেন থাকলে দেখো, or we're going to move on to the next question, but take a good look and see if you want to ask me anything.
আচ্ছা স্যার আমরা এখানে লাইক আমরা ফ্রিকশন কেন ধরছি না?
Because the question doesn't imply that. When the question essentially tells us that over a pulley, they didn't say smooth pulley, but they only said that there is a pulley. If the question does not specify that it's there's a friction, we don't have to consider this in our question.
এই জন্য হচ্ছে কি কর্টার মধ্যে 900 নিউটন ফোর্স ফিল করে
full 900 হচ্ছে, but if the question said that this is a rough pulley or there is some friction in the shaft and the pulley wheel that exerts, let's say 10 newton force, যদি এরকম হতো যে the friction over here at this location is 10 newton, তখন আমাদের এটা 800 হতো না, 900 হতো না, this is going to be 10 newton short of 900. So in that case this force would have been 890.
800
বুঝছো?
Yes, sir. Thank you.
Good. Questions, anyone?
No, sir.
Acha. Anything else from this page? 12 কোন সমস্যা কারো? 13?
Sir, 14 সমস্যা।
14 তো সমস্যা হওয়ার কথা না। আচ্ছা 14 অ্যাকচুয়ালি হ্যাঁ 14 একটু ঝামেলা আছে, ভ্যারিয়েবল দিয়ে ম্যাচ করতে হয়, দেখাচ্ছি। Have a look at question 14. A uniform rod XY of weight 10.0 Newton is freely hinged to a wall at X. It is held horizontal by a force F acting from Y at an angle of 30 degrees to the horizontal as shown. What is the value of F? The problem of this question is that the length of the rod is not given. So we have to assume the length. Let's assume that the length of this shaft is X. So this much distance should be how much? You have to understand this is a uniform rod, so this should be the midpoint. This is supposed to be X by 2. And how much should this be? This should be how much? এটার লেন্থ কত হবে? Anyone have a look? There is a right angle triangle. This is the hypotenuse. No one?
Sir, X এর opposite
X
সাথে
cos
কি X
60.
It can be written in two versions. It can be either written as x cos 60, that's also perfectly good. Or you could also write it as x sin 30. That is also equally good. Both of them will essentially give you the same value. দুটোই হবে, দুটোই exactly same. If you put the values in calculator, you'll find the cos 60 value হচ্ছে half, sin 30 value হচ্ছে exactly half. So you could use any of these. So if we now go for the calculation for a moment, this is going to produce a clockwise moment about this hinge point, clockwise moment, and this is going to produce anti-clockwise moment. So f into, let's say, x cos 60 should be equals to 10 into x by 2. You don't have to bother about x because x will be crossed out on both sides. So calculate the value of f, see how much you get.
আমি বুঝি নাই
কোন পার্টটা বুঝো না বলো?
ওই যে f into x cos 60
F is the force that is working on the body along this string, and this red line is the perpendicular distance of this force from the pivot point. This is a right angle triangle where the hypotenuse is xy because this is 90 degree. This is 90 degree. So we can either calculate this in terms of the cosine value for this angle, or we can go for the sine value for this angle. If you consider the 60 degree as your angle, this is your adjacent side. If you consider it for 30 degree, this is your opposite side. For opposite side, sine. For adjacent side, cos. বুঝছো?
জি স্যার।
জি স্যার
স্যার সি হবে answer।
I'm not sure which is going to be, whatever it comes. C na D?
না স্যার
C sir, x cos 60 যদি x by 2 হয় তাহলে x by 2 x by 2 কেটে যায়।
C হয়। আশা বুঝছো?
হ্যাঁ মোটামুটি বুঝছি
তারপর anything else from page number 12? Sixteen should be easy problem for you to solve now because we did talk about the ladder cases. Which one did you get your correct answer for number 16?
Sir, B.
Yes, B is the correct response. Is this a condition for equilibrium? I mean, would the ladder be stationary? Or can the ladder rest in this condition?
No, sir.
Good. Why?
Frictionless ground, sir.
Frictionless ground. Beautiful.
ফোর্সগুলো এক্সটেন্ড করলে একটা সিঙ্গেল পয়েন্ট দিয়ে সবগুলো পাস করে না তাই?
Beautiful, Zarif. That's exactly what I was looking for. Both of you are equally correct, but you have different expressions. So, যদি কোনো সময় theoretical question আসে তোমাদের বুঝে আনসার করতে হবে যে কোনটা লিখলে কারেক্ট মার্কস দিবে। Or if you're not sure, you can write both of them.
Sir.
Yes.
Sir, zero resultant torque. এটা মানে কি বলবো? Pure turning effect.
Zero resultant torque means equilibrium of moment. Like zero resultant force means equilibrium of forces, like that. Number 17, page number 17 no problem. Bolo, page number 13 থেকে problem bolo. I shouldn't point out problems. Anything from page number 13? No. 14?
Sir, 23.
20?
3.
23 দেখবো।
জি স্যার।
A uniform beam of weight 100 Newton is pivoted as shown at আচ্ছা এটার পরে কি জানো নাই হয়ে গেছে, আচ্ছা at P হবে, at P as shown, P নাই এখানে, হ্যাঁ P তো গায়েব হয়ে গেছে।
না স্যার বুঝেছি কি হবে।
It is pivoted at P as shown. So the beam is uniform, that's important, but it is pivoted at P point, so it is not pivoted at the center of gravity. So important observation. Weight of 10 Newton and 20 Newton are attached to its ends. The length of the beam is marked off at 0.1 meter intervals. So each of these small sections represents 0.1 meter. At which point should a further 20 Newton be achieved? At which point should a further 20 Newton be attached to achieve equilibrium? So question tar mane ta age bujho. What I need you to understand very clearly that in this case the question is already telling you that the setup is not in equilibrium. You need to add some additional force to make the system come into equilibrium. Check this out.
আরেকবার বলুন স্যার।
The question says, at which point should a further weight of 20 Newton to be attached to achieve equilibrium? Which means the question is already telling you that the system that is drawn over here is not in equilibrium. To make it come into equilibrium, you have to attach a 20 Newton force somewhere on the object. And what is that location? What should be the location of that 20 Newton force or 20 Newton weight? That is what you're trying to find out. So if you go for piece by piece, have a look. Try to count the total length of the beam. How long is that beam altogether? 0.6 plus 0.4, 1 meter. So B should be the midpoint. So the weight should be working from this point. So I'm going to label the weight first because that is going to be a default force that we have to work with, which was not given into the question intentionally. So how the weight of 100 Newton should be working at this location. So I'm labeling the weight. And let's say the F force should be placed somewhere around. Now, to guess where this F force is going to be, should be placed on the left or whether it should be placed on the right, we can calculate the total moment available in this situation. You can see it very well from the figure that this is going to produce an anti-clockwise moment, this is going to produce an anti-clockwise moment, whereas this is going to produce a clockwise moment. Make sense?
স্যার বুঝে কি আমি ওয়েট ধরি ইমেজ করছি।
আচ্ছা, সো ওয়েটটা ধরলে ইজিলি করতে পারবা। সো এদের হিসাব করবা, তারপর যতটুকু বেশি হয় ওটাকে ব্যালেন্স করার জন্য কোন পাশে বসাবো সেটা বের করো, তারপর এটাকে এক্স ডিসটেন্স অ্যাজিউম করে নিয়ে হিসাব করে চলে আসবে। তারপর anything else from this page, anyone? 29.
জি স্যার 29।
I knew it. 29 is a good question which can prove to be difficult to a lot of kids. I'll be explaining question number 29 in detail slowly, so I want everyone to understand. So if you have a question, you tell me. The diagram shows the two pulley wheels connected by a belt. Wheel Q is driven by a motor and rotates clockwise at a constant rate. So, bam. Wheel Q puts tension in the top portion of the belt, which in turn drives wheel P. So this is the belt which is under tension. The lower portion of the belt is slack and has no tension. So the force that would be transferred from Q to P will be exclusively working by one belt, not by the both belt, because the tension in this one is 0. So what would have been a much better figure? I mean, if they just drew this line to be a bit curved or to be a bit slack. এটা করলে স্টুডেন্টদের জন্য বুঝতে সুবিধা হতো, but they didn't do this because they didn't want to. So what you need to understand that there is no tension in the lower part of this belt. There is significant tension on the upper part of the belt. So the force that will be transferred from the Q to P will be only working through one part of the belt. That's the top portion of the belt. The belt infusion is, for those of you who have who don't understand this thing properly, it's a very simple scenario. I mean, whenever any bicycle or any rickshaw sprocket work, that is the pedaling wheels, the two pedals that actually rotate a much bigger disc, which uses a chain to rotate the driving shaft for the two rear wheels. So the tension or the force is exerting from the top part of the chain, but the lower part simply travels back to the wheel shaft just travels back to the wheel shaft and it turns over and eventually becomes part of that upper chain. So all the force that transfers in that process is only working through the upper part of the chain. The lower part doesn't work. So that's the practical example for a situation like this. So you can consider this is the location where where the pedaling occurs. Where this is the actual location of the rickshaw wheel, the rear wheel axle shaft. But in this case, according to the question, the scenario is just opposite in the sense that for a typical bicycle, we apply force over here, which in turn rotates this one. But this question says that this was being rotated by some motor. This in turn is rotating this one. So in this case, energy is transferring from the small wheel to the big wheel, not the other way around. So I brought about the example for the rickshaw or the bicycle scenario to make you a good understanding for how this is working. So we're gonna go back to the question. The lower portion of the belt is slack and has no tension. The weight of the belt and frictional forces are negligible. Okay, so we don't have to bother about their weight and there is no friction. The diameter of P is 150 meter. The diameter of Q is 100 meter. The torque applied to Q is 3.0 Newton meter. So this the torque over here is 3.0 Newton meter. What is the tension in the belt and the torque of the wheel of the P? So what I can draw, let's say the tension in this belt is T, which is working this way. You might wonder, so tension erokom keno hobe? Because for a rope or for any part, tension is the force that always works in outward direction, and they balance each other out. But they produce a static extension or some strain energy into the body, which is not part of this question. We're gonna show up in our elasticity chapter. So you need to understand that the force is not working here. Force is only working over here. So we cannot work with the entire diameter because these are the pivot point center for these two situations. So we need actually the radius of these two forces. So over here, if we want to label the radius, how much should be this radius? What should be the value of this dimension?
100 millimeters.
No.
0.01 meter.
No. Read. This is what?
0.005.
Oh, sorry, আমি এখানে
50 মিলিমিটার।
এখন ঠিক আছে 0.05 মিলিমিটার। আর এটা কতটুকু হবে?
স্যার দুটো জিরো হবে
না
75 millimeters.
না দুটো জিরো হবে না। আবার দেখো এটা ঠিক আছে বলবান 100 divided by 2 divided by 1000 করলে তো 0.05 হয়। এখানে কি জিরো একটা বেশি হবে?
না স্যার ঠিক আছে 0.0।
That's what I thought. আর এটা হবে হচ্ছে 0.075। এই পর্যন্ত বুঝা গেছে কিনা?
জি স্যার।
বাকিটা খুব ইজিলি করতে পারবা। The torque produced over here should be equally transferred over here. Sorry, so এখন আমরা যেটা করতে হচ্ছে tension in the top belt. So প্রথমে আগে আমরা এই ইনফরমেশন দুটাকে ইউজ করে 80 টা বের করব। Which means 3.0 equals to T into 0.05. This is for the right wheel. এখান থেকে এটা ইউজ করতেছি। এখান থেকে তোমার T টা বের হয়ে যাবে। T is found. এবার এই T টাকে আবার এই ইকুয়েশন ইউজ করব। সো এই হুইলের জন্য আমাদের মোমেন্ট অর টর্ক যেটাই বলো না কেন একই জিনিস। That would be that value of tension. You're going to bring it up from here multiplied by the radius 0.075. স্টুডেন্টরা যে ভুলটা করে এখানে সেটা হচ্ছে they go for the calculation for diameter. But because the question says there is no tension in the bottom part of the belt, you cannot use the entire diameter because this perpendicular distance from the force or the belt from the pivot, which is the center of the wheel, is not the diameter. That is the radius. That is the key point to be mistaken. So calculation গুলো করে দেখো আনসার কত আসে। আনসার ম্যাচ না করলে আমাকে বলো। And if you have no questions, we'll move away from here after a while. We'll take a small break for 7 minutes for Maghrib prayer. We'll resume class at 7:05. Class. We'll resume recording. So, এটা নিয়ে এই কোশ্চেনে ফার্দার কার কোনো কোশ্চেন? Anyone? Hello? কথা শোনা যাচ্ছে?
নো স্যার।
মানে কথা শোনা যাচ্ছে না নাকি প্রবলেম নেই?
না স্যার প্রবলেম নেই।
আচ্ছা ঠিক আছে। Okay, so let's move on to the next thing. This is a repeat question, repeat question, repeat question, repeat question. Yeah, this is a good one. 34%.
না
জি স্যার।
আচ্ছা 34 একটা আলাপ করি।
না না এটা পারি।
দেখো the diagram shows a charge balancing game. So well, we see a setup. Setup is pretty self-explanatory. The wooden rod is uniform and all the rings are of equal mass. Two rings are hung on peg 13 and one on peg 1, on which hook must a fourth ring be hung in order to balance the rod. So এখানে আমাদের কোনো কিছু mass দেওয়া নেই, none of the masses are given, so we need to simply calculate the information with the available visual data that we have. Let's assume that each of the ring has a mass of m, and we can count how many distances there are. For example, 8 is the point on which where the pivot is located. So distance 1, 2, 3, 4. So we can count each of the gap as one distance value. So here the anticlockwise moment that is produced by how much? 1, 2, 3, 4, 5, 6, 7. So this would be 7m. That is the anticlockwise moment. How much would be the clockwise moment available from here? 1, 2, 3, 4, 5. 5 into 2, which means 10m. বুঝাচ্ছে?
yes sir.
So this would mean that now we have a clockwise moment bigger, so we need to have a bit of anti-clockwise moment. So we need to place it on the left side. How far apart? We need to have 3m additional anti-clockwise moment. So we have to place it, because we have assumed the mass to be m, so we have to place it 1, 2, 3. We have to place another ring over here, so that this will produce another 3m, so that your clockwise anti-clockwise moments is equal to clockwise moments. So the number of pegs should be 5.
স্যার আমি তো 5ই পেয়েছি অ্যানসার। তো
আনসার 5 না? আনসার কি ভুল হয়েছে? কি একটু আনসার চেক করো তো।
না না স্যার আমি ভুল দেখছি, 5ই অ্যানসার।
আচ্ছা প্রসেসটা কি বুঝা গেছে সবার? It's a pretty simple one, but the difficulty can happen if you are set in your brain that without numbers I cannot do calculation. There is no number given over here. You just have to assume these variables and work with the visual data that you have. That's the challenging part over here. Page number 16. Anything from page number 16?
স্যার একটু নিচে যাব, 39 স্যার। এই যে অ্যানসার হচ্ছে গিয়ে ডি, সেটা বুঝেছি, কিন্তু নিচের যে ফোর্সটা স্যার, এই ফোর্সটা কি, মানে এই ফোর্সের ফাংশন বুঝি।
আমি আচ্ছা বলতেছি। In this case, the question that does not tell us at all what is the reason of the forces that is exerting. I mean, what is the sources of the forces that is not given to us in this question. We are simply given the forces, irrespective of how these forces came into existence, and we are asked to calculate the resultant force and resultant torque. So this downward force might be weight, might come from something else. There might be something hanging from a weightless bar at this position. So it could be anything. So the reason of the force existence is nothing that we need to bother about. বুঝা গেছে কি বলছি? যারা
কেটে কেটে যাচ্ছিল আপনার কথা।
we don't have to bother about how did these forces come into existence. As per the question, the forces are given to us, and all that we have to consider is how these forces work together to achieve resultant equilibrium force or equilibrium of moment. That's all we have to judge, and that's what we have to work with. ঠিক আছে?
তাহলে স্যার আমরা এখানে 112 নিউটনসটা বাদ দিলাম।
Acha, for the calculation, like I said in the earlier case, that in any case, for any scenario of moment calculation, you will always have the privilege to choose your pivot point. So you could choose your pivot, because these distances are all given from the central force. So if you try to calculate your moments considering this point as your pivot, or for this one as your pivot, or for this one as your pivot, you can altogether get rid of the moment calculation for this vertically downward force. You can simply calculate the moment by this one and compare these two. That works.
আচ্ছা 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 স্যার যদি
ওই লজিকের জন্য
লাইক অন্য পয়েন্টকে পিভট ধরতাম তাহলে
যদি অন্য পয়েন্টে পিভট ধরো তাহলে সেক্ষেত্রে তোমাকে আবার একটা র্যান্ডম ভ্যারিয়েবল আনতে হবে। ফর এক্সাম্পল লেটস সে ইফ ইউ কনসিডার হিয়ার অ্যাজ ইওর পিভট পয়েন্ট, দেন দ্য ডিসটেন্স অফ 42 নিউটন ফর লেটস সে, আচ্ছা আমি একেই দেখাই, ডোন্ট ওয়ারি, এখানে আনছিলাম আনি নেই। So let's say if I want to consider this point over here as a pivot point, random একটা point, in that case you have to assume how far is this from one of the forces. So if you assume that this distance over here is x, then you need to understand that if you consider this as a pivot point, this will be producing a clockwise moment of 112 into x. This will produce a anti-clockwise moment. This should be 42 into 50 minus x. And this will produce another anti-clockwise moment that will be equal to 70 into 30. Now 30 plus x. You simply have to bring about this x over here. Now also if you add all of these up together, you will find out that x will be gone. And the resultant of the total value, sum of these three things, I mean clockwise, I mean two clockwise force, one anti-clockwise force. So if I do this 42 into 50 minus x, this is the only anti-clockwise force moment, should be equals to 112x. ভুল লিখছি না, এটা তো ক্লকওয়াইজ, এটা ক্লকওয়াইজ, সরি এখানে প্লাস হবে, ভুল লিখছি। We have two clockwise moment and one anti-clockwise moment. I mess up the symbolization. This should be equals to, this is supposed to be happening. Now if you wonder whether should this happen or not, you can eventually calculate this out, and ultimately if you do the calculation properly, you'll find out that ultimately you'll get 0 equals to 0. You'll end up with this thing, which means everything is obliterated, which means the total momentum is 0. That's going to work for you.
Okay sir.
বুঝতে পারছি?
জি স্যার।
Good. So that concludes the 3.2, which is the end point of our MCQ solution class. So we're gonna have to go for the paper 2. We don't have much time, but I'm gonna start paper 2 because I want to give you some heads up for the solving of paper 2. The first heads up that I would like to discuss, that which are the questions that I would personally prefer to discuss in my next class, and which are the other questions that you should definitely try as your homework. So I'm going to give you some numbers that I would like you to try. I mean, a must try, so that you can tell me about this thing. Question গুলো mark করো বা কথা লিখো।
স্যার নেক্সট ক্লাস কি স্যাটারডে হবে নাকি বলা যাচ্ছে না এখনো?
আচ্ছা বলতেছি। Why are you asking me this?
আপনি না বলেন ফ্রাইডেতে চিটাগং যাবে?
এটা আমি কাকে বলছি?
স্যার আমাদের সবাইকে
কখন বলছি?
লাস্ট
বলছিলাম, হ্যাঁ কিন্তু ভুলে গেছি আমাদের বলছি। আচ্ছা তার মানে তোমাদেরকে শুধু বলছিলাম, হ্যাঁ নেক্সট ক্লাস স্যাটারডে তো অবশ্যই হবে না, স্যাটারডে তো হবে না, এটা শিওর। সো I definitely plan to come back by Monday. মানে I plan to take classes from Tuesday. আর সো তোমাদের স্যাটারডে ক্লাস হবে না এটা ফর শিওর। সো নেক্সট ক্লাস হওয়ার পসিবিলিটি, আর্লিয়েস্ট পসিবিলিটি হচ্ছে ওয়েডনেসডে। আর যদি আমাকে চিটাগাঙে বেশি সময় থাকতে হয় তাহলে আমি তোমাদের মেসেঞ্জারে জানাবো, ডোন্ট ওয়ারি অ্যাবাউট দ্যাট। ঠিক আছে
স্যার একটু বেশি দিনই থাকেন, কতদিন পরে যাবেন?
সাথে তুমি এগুলা কি বলো?
স্যার ও বাকি দিতে চায় কিছু না, ও আপনার জন্য কোন ফিলিং।
Well, I really want to stay there for as long as I want, but the thing is, for reasons I cannot explain, I should not be in Chittagong for a long time.
কোভিড এর কারণে?
For reasons I cannot explain.
ওকে আচ্ছা স্যার, সাবধানে যায়েন, করোনা যাতে না লাগে।
I want to be alive. I'll try to take precautions, but then again, I'm a very callous person and careless person, so I don't know what's going to happen in the long run. Anyway, I'm giving you some numbers which I'd like to discuss in the next class for sure. So please do try these questions if you haven't tried the paper 2 worksheet, or if you have done the paper 2 worksheet, I salute you. But I would like to give you some numbers. নাম্বারগুলা কেউ একজন লিখো, আর হচ্ছে পরে আমি এগুলা তোমাদের গ্রুপ চ্যাটে দিয়ে দিব। 1, 2, 3, 5,
So 1, 3, 5.
2 also.
1, 2, 3, 5, 7, 8. 8 মনে হয় আমরা করছিলাম না? এই কোশ্চেনটা করছিলাম কি আমরা কাইনেটিক্স চ্যাপ্টারে করছিলাম আমরা এই গ্রাফটা?
না স্যার।
না স্যার এটা করিনি।
লেখো তাহলে 8 এইটা করা লাগবে 9C 10 10টা স্টার মার্ক করো এই গ্রাফটা অনেক ইম্পর্টেন্ট ভালো করে বোঝা লাগবে 13 16 20 এই কোশ্চেনগুলো অবশ্যই হোমওয়ার্ক করবা নেক্সট ক্লাসে যাতে আমি এগুলো ডিসকাস করার সময় তোমরা রেসপন্ড করতে পারো কারণ হোমওয়ার্ক না করলে আমি যখন ডিসকাস করব তোমরা হ্যাক করে তখন কোশ্চেন পড়া শুরু করবা by the time you'll be reading the question I'll be 50 to 60% into my discussion so it's going to be a mess to make the class worthy for your time and my time as well please do try these questions so I'll take one question for today's class because we have still 10 minutes left which is going to be I'll take one question then we'll call it a day so a question একটু আলাপ করি সেটা হচ্ছে যেটা স্টার মার্ক করতে বলছিলাম sorry question number 8 let's have a look at question number 8 define force what is the new definition of force applicable from A levels you cannot write the qualitative definition to score mark. You cannot write this is the push or pull on any object. That's the old definition. That's not incorrect, but it's not acceptable at your level anymore. You cannot write force is equals to mass into acceleration. That was applicable for your O levels. This is true, but this is not applicable because this is not exactly how Albert Einstein, Isaac Newton defined the force as. The way he defined, which is introduced in your A levels from AS level, is that force is the
causes something to accelerate
no
a certain direction.
No rate of change of momentum delta p by t that is the only definition that is acceptable if you want to write it into symbols if you want to write that f equals to delta p symbol divided by t symbol then you have to go ahead and eventually write what those symbols mean so what I personally like that you either write into words or if you want to write it into equational form write word equation so you can write force equals to long division line numerator লিখবা হচ্ছে change of momentum denominator লিখবা time
Sir,
follow
what is exactly momentum?
that's to be seen for the class lecture from chapter 2
Okay.
chapter 12 class lecture দেখবা না বুঝলে আমাকে মেসেঞ্জারে নক করো
Okay.
number B two spheres approach one another along a line joining their centers as illustrated in figure 3.1 when they collide the average force acting on sphere is FA and the average force acting on sphere B is FB the forces act for time TA on sphere A and time TB on sphere B state the relationship between FA and FB and TA and TB well this is pretty simple FA equals to minus FB TA equals to TB forces are vectors that's why you have to introduce the minus sign because they are vectors and time is a scalar so time is equal simple user has answers in 1 to show that the change in momentum of sphere A is equal in magnitude and opposite in duration for the time of momentum B so F equals to minus FB from the equation you're going to convert them into delta B by T TA TB কারাগারি চলে যাবে so ওখান থেকে এটা করতে পারবে you try this out you should be able to do that I'm very much just to go for this one have a look at this graph have a good look for the spheres in B the variation with time of the momentum of sphere A before, during, and after the collision with sphere B is shown in figure 3.2. So on the y-axis we have the momentum plotted. On the x-axis we have the time plotted. And this one is the uniform velocity of sphere A, which is starting to change at this time instance. Time axis is not labeled, so I'm gonna say talk about this time axis value by in terms of number of divisions. So let's say this is 10 division, this is 20 division. So for 10 divisions time, the sphere A is going uniform velocity. This is where the velocity starting to get lower. So this is exactly where the collision gets started. As long as the velocity is undergoing a change, the force is continuously being exerted. The force is being exerted over the duration of this many divisions onto sphere A, because change of velocity means acceleration. Acceleration means force is exerted. At this division mark, the object gets the final velocity, which is maintained over the rest of the duration, which means this is the time frame where the collision gets finished, which means this is the time frame where the two objects detaches from each other. This is the primary thing that you need to understand to solve for this question. But I would like to further discuss certain parameters of this graph. That is, here this object is going from left to right. Have a look. The sphere A was going to the right, and here the momentum of sphere is shown as a positive quantity. So in this case, we are considering towards right is a positive direction for vector quantities. The object sphere A starts from 6 Newton second momentum, and it still keeps on moving to the right up till this mass division. This is the point where the momentum becomes zero. Momentum becoming zero means that this is the point, this is the time instance where the sphere A comes to stop. From this point onwards, the sphere A starts to move in the backward direction. That's the significance of negative momentum, or which can also be translated into negative velocity. So for this entire time instance, for this entire 30 divisions, so if I go for step by step, for the first 20 divisions, the sphere A was moving at constant velocity towards right. At the 20 division instant, the collision gets started. At the 30 division time value, the sphere A is momentarily at rest. And from this point further, it starts to go in the backward direction. The collision finishes at 35 division of time mark. So it also a graph to physical description. The question says the momentum of sphere B before the collision is also shown in figure 3.2. Complete the figure 3.2 to show the variation in time t of the momentum of sphere B during and after the collision with sphere A. So we are expected to draw this same graph for sphere B. How can we draw that? I want to show you that part. So what I need to understand that as long as the sphere A doesn't experience the collision, sphere B will not also experience the collision. Let me finish up the drawing, then I'll take your questions. But for the time, shune jao. So sphere B will maintain its velocity exactly at the same value up to this division mark. So this is our first part. This is where the collision will get started, and then as the momentum of the sphere A is going down, momentum of sphere B should be going up, because we know from our knowledge that by Newton's third law, delta PA should be exactly equals to minus delta PB. So for the cases when the momentum of sphere A is reducing, momentum of sphere B should be increasing by the same magnitude and over the same duration of time. Now, have a count, other than actually measuring up the value over here, have a count how many divisions did this initial momentum of sphere A drop down from the starting value. So what I'm trying to mean is that how many divisions did it drop down? Count.
12.
No. 12 plus 6.
6. 18.
18, right? So sphere A momentum got reduced by 18 division. So sphere B momentum should increase by 18 division as well over the same duration of time. How much is the duration of time over here? 15 division. So this line is going to be another straight line which should span out for 15 divisions, should rise up by 18 divisions. So count 18 division up from this point. Have a look. 3, 5, 18, 8, 10, 18. This is 18 division above and 15 division horizontal. So this should be the end point of the sphere B's value. So this would be my point right over here, right over here. Check this out. And then from this point, that momentum will be maintained uniformly. So we're going to have to continue this part till the point this graph is continued. So we're going to continue this part graph horizontally exactly up to the part of the graph that is given for A as well. So this is the blue part that you are expected to draw. That's what you should draw. Now I'll take questions. কেউ কিছু কোনো পার্ট না বুঝলে বা কোনো পার্ট কনফিউশন লাগলে আমাকে বলো। Anyone?
স্যার আমি লিভ নিয়ে আমার আরেকটা ক্লাস আছে স্যার
You can leave at 7:30 p.m. mark at without my permission.
স্যার এটা ইউটিউবে দিয়ে দিবেন না কয়েকটা নাম্বার মিস করেছি
Yes. Do you guys have any question about this part of the drawing? Anyone?
No, sir.
No, sir.
Beautiful. So that will conclude our today's class, and we'll call it a day. I'll hope to meet all of you on Wednesday. We'll definitely keep in contact from the messenger group chat. So all the best. Stay safe. Allah Hafiz.
Sir, sir.
Yes, sir.
আমাদের কি ক্লাস টাইম চেঞ্জ হয়ে যাবে, কারণ গ্রিন হিলতে যারা আছে তাদের তো আবার একটা থেকে ক্লাস।
আগে ক্লাস শুরু হোক, পরে দেখতেছি।
ওকে।